Every crust you've ever loved, every bark that peeled off a brisket, every golden sear on a steak that made you close your eyes, all of it was created by one single chemical reaction happening in milliseconds, and most cooks have never heard its name. Welcome to the most important thing you'll ever learn about cooking meat. By the end of this video, you're going to understand exactly what's happening on the surface of your steak when it hits a screaming hot pan. And that understanding is going to change the way you cook forever. The reaction is called the Maillard reaction, named after a French chemist named Louis-Camille Maillard, who first described it in 1912. Now here's the wild part. Maillard wasn't even trying to understand cooking. He was studying how amino acids behave in the human body. He accidentally stumbled onto the chemistry behind the most delicious thing in the world. We'll come back to that strange origin story in a minute because it gets even more interesting. But first, what actually is the Maillard reaction? At its core, it's a chemical reaction between amino acids and reducing sugars. When heat is applied, typically above 280 to 330 degrees Fahrenheit, those two compounds start reacting with each other. And as they react, they don't just create one new compound, they create hundreds of new flavor and aroma molecules simultaneously in fractions of a second. That nutty, smoky, savory, almost addictive smell when meat hits a hot surface, that's not one thing. That's a symphony of hundreds of compounds firing off at once. Here's the thing that blows most people's minds. The Maillard reaction is not the same as caramelization. A lot of cooks use those terms interchangeably, but they're completely different processes. Caramelization is purely sugar breaking down under heat. The Maillard reaction requires both sugar and protein to be present. That's what makes it unique to meat, bread crusts, roasted coffee, and seared vegetables. And that distinction matters when you're cooking because the techniques that drive one reaction are actually different from the techniques that drive the other. So now you know what it is. But here's the open question I want you to hold on to. Why do some sears taste dramatically better than others, even when both were cooked on high heat? The answer has everything to do with a few variables that most home cooks are unknowingly working against. We're getting to that. Let's talk about the conditions the Maillard reaction needs to go absolutely wild on your meat. The first is temperature, and not just any heat, but dry, concentrated, direct heat. The reaction slows dramatically if there's moisture present on the surface of the meat. This is one of the biggest mistakes home cooks make. They pull a steak out of the fridge, throw it straight into the pan, and wonder why it's steaming instead of searing. What's happening is simple physics.
The moisture on and just below the surface of the meat has to evaporate before the surface temperature can climb high enough for Maillard to kick in. By the time the moisture is gone, the interior is already overcooking. The fix? Pat your meat completely dry before it ever touches heat. Dry brine it uncovered in the fridge overnight if you really want to go all in. Dry surface equals better crust. Every single time. The second variable is surface contact. The Maillard reaction can only happen where the meat is actually touching the heat source. This is why a cast iron skillet produces a better crust than a thin stainless pan. Cast iron holds heat like a furnace and doesn't drop temperature when cold meat hits it. A thin pan loses heat fast, and the moment the surface temp drops below that 280-degree threshold, the Maillard reaction stalls. You get gray, steamed meat instead of a proper crust. Same principle applies to grilling. When you put too many steaks on the grill at once, the grate cools down and you lose the reaction. Give your meat room to breathe and give your cooking surface time to recover. Now here's the third variable, and this is the one that separates good cooks from great ones. The Maillard reaction produces different flavor profiles depending on the specific amino acids and sugars present in the meat. This is why a dry-aged ribeye seared in butter tastes completely different from a fresh sirloin seared in canola oil, even if you do everything else identically. Dry aging breaks down proteins into more reactive amino acid compounds, which means more raw material for the Maillard reaction to work with. More reactive compounds, more flavor molecules, more complexity in the crust. That's the science behind why dry-aged beef commands a premium price, and frankly, deserves every penny. Pitmaster's tip time. If you want to push the Maillard reaction even harder, add a very thin layer of something with sugar and protein right before your final sear. A light brush of clarified butter mixed with a touch of Worcestershire sauce on a steak right before it hits the heat gives the reaction more fuel. You'll see the color deepen faster, and the crust will be darker, crunchier, and more complex. Competition barbecue cooks use versions of this trick on brisket and ribs. Now you know why.
Let's go back to Louis-Camille Maillard for a moment, because his story has a strange, almost poetic twist. He published his findings in 1912 and named the reaction after himself, except he didn't name it after himself. He just published the research. It was later scientists who attached his name to it, posthumously. Maillard actually died in 1936, not particularly famous. It wasn't until the 1950s that food scientists began applying his work to cooking chemistry, and it wasn't until the 1980s that the culinary world started paying serious attention. A century after his discovery, his name is the answer to why your steak tastes like nothing else in the world.
Not bad for an accidental finding. Now here's the escalating truth I promised you earlier. The reason some sears taste so dramatically better than others. It's not just technique, it's time. Specifically, the length of time the surface of your meat stays in that 280 to 400 degrees sweet spot where Maillard is working. Too fast and you don't get full crust development. Too slow and you overcook the interior before the exterior is done. The reverse sear method, where you bring the internal temperature up slowly in a low oven first, then finish with a screaming hot sear, is the single best way to maximize Maillard time on the surface without destroying the interior. You get all of that complex crust chemistry without any gray, overcooked meat underneath. It's not a trend, it's applied science. And here is the most surprising thing about the Maillard reaction, the one fact that tends to stop people cold when they hear it. Scientists have identified over 600 distinct flavor compounds that can be produced by Maillard reactions in meat alone. Over 600. Each cut, each fat content, each aging process, each cooking fat, and each temperature produces a slightly different subset of those 600 compounds. Which means when a pitmaster says their brisket tastes like nothing else in the world, they're not being poetic, they're being chemically accurate. No two Maillard reactions are ever exactly alike. Every crust you've ever eaten in your life was a unique chemical event that will never happen again in quite the same way. That's the Maillard reaction. That's the science behind every bark, every sear, every crust, and every bite that's ever made you stop mid-sentence. You're not just cooking meat anymore. You're running chemistry experiments, and now you know how to win. What's the best sear you've ever tasted? Drop it in the comments. A restaurant, a backyard cookout, a memory. I read every single one. Hit subscribe so you never miss a bite, and next time we're going deep inside the world of dry aging, and the results are going to genuinely surprise you.